Hello everyone, my name is Siddhi and today I'm going to talk about mobile to cloud offloading techniques. Why the need to offload data on a cloud? From past few decades, we have seen the popularity of mobile devices. This is possible because of excellent software and hardware architecture and designing of mobile devices. Features like voice call, face recognition, video call are made possible because of it. But these applications require high computation power for execution. Hardware consumes a lot of power too. This is not acceptable by the users. There hasn't been a phenomenal research in battery development from past few years. As users want excellent performance with minimum usage of battery and shorter execution time of the process, there has to be some other way around. Hence the need to offload data on a cloud. What is cloud offloading? It means to offload data on a cloud server which is rich in resources in order to process the tasks or applications faster. By doing so, we minimize the load on the client, and that is mobile devices in our case, and also minimize the battery usage of the mobile devices and maximize the runtime of the applications. Cloud offloading differs from traditional client-server architecture, as in cloud offloading, the applications or programs are moved to the servers outside the computing environment. There has been an advanced research in cloud computing, which has given rise to a couple of clouds in the sky. Hence, selecting the right cloud from the sky to offload data is important in order to get minimum battery usage and maximum runtime speed of the applications. In order to select the best cloud, it is necessary to select the best cloud path. Hierarchy structure of cloud path selection is as shown in the figure. It has three categories: target, criteria, decision. At the target level, the objectives of the applications or tasks to be offloaded are being mentioned by the user. In criteria hierarchy, based on the application or tasks, the criteria are being selected. And in the decision hierarchy, that is the last hierarchy or the level, here the cloud has been selected. The cloud which satisfies all the criteria for the applications or the tasks is being used to offload the data. Now the question arises, when to offload the data on the cloud server in order to reduce the energy consumption of mobile devices to offload the tasks on the server. So it has been mathematically proved that if D by C ratio, that is data to be offloaded and C, the computation to be performed, is low, then the given offloading will consume less energy. If not, then the given offloading will consume more energy and it won't be beneficial to offload the tasks on the server. Offloading methods. The methods should minimize the latency, battery usage, runtime, and maximize the efficiency and provide reliability and security to the offloaded data. These methods are divided into three subcategories. Offloading techniques used to find the shortest path and optimal cloud from sky for offloading, saves power and energy of mobile device. Scheduling techniques used to find the best way to schedule the offloaded tasks on cloud using different scheduling algorithms, thus minimizing the runtime period for processing of tasks or application. Third, but the most important one, security techniques used to protect the data from the hackers and to set up reliable and secure communication between client and server. So first, I'm going to talk about offloading techniques. Computation offloading. It means to offload a task or application's code fully or partly on the server. There are two types of computation offloading. First is coarse-grained offloading method. In this method, the entire code of the application is been offloaded on the server. The upside of this method is that there is no need to revise or modify the code. But the downside is there is a high transmission overhead as the entire code is been offloaded on the server. The second type of computation offloading is fine-grained offloading method. In fine-grained offloading method, to handle partitioning and state immigration, programmers need to revise the code. The part of the application which consumes a lot of power is offloaded on the cloud. In this part, those parts are offloaded on the cloud which are energy hungry and not the entire application or tasks, unlike coarse-grained offloading method, thus saving the application and device from transmission overhead but increasing the burden on program and increasing the programming complexity. Depending upon the needs of the user, a trade-off between cost and runtime processing is obtained when one of the computation method is been adopted. Another technique in cloud offloading is fuzzy analytical hierarchy process. Fuzzy analytical hierarchy process is an extension of analytical hierarchy process. Analytical hierarchy process is used for making decisions such as forecasting, planning, etc. Along with all the functionalities of analytical hierarchy process, fuzzy analytical hierarchy has a membership function mu. This function defines a transition ranging from 0 to 1. Evaluation matrix for cloud path selection is obtained and a cloud with highest performance is used for offloading. Another cloud offloading technique is analytical hierarchy process and fuzzy techniques for order performance by similarity to ideal solution. Analytical hierarchy process is used to determine the relative importance of set of alternatives. This process gives a numerical weight or priority for each element of the hierarchy. The result of pairwise comparison on n criteria is as shown in the A matrix. Here AII is equal to 1 and AIJ equals 1 upon AIJ. Fuzzy topsis is used to obtain the final ranking of the clouds. The process steps can be outlined as follows. Establish a decision matrix for the ranking. X is a decision matrix in our case as shown in the figure. N is equal to number of criteria. M is equal to number of alternatives. Next, calculate the weighted normalized decision matrix. Then, determine the positive ideal and negative ideal solutions respectively by using the formulas for A plus and A minus. This is the membership function of linguistic values, and this is linguistic values and their fuzzy ranges are being shown in the table. Then calculate the distance of each alternative from A plus and A minus using the Euclidean distance formula. Then calculate the relative closeness of the ideal solution by using the formula Ci asterisk is equal to Di minus upon Di plus plus Di minus. Then rank the alternatives according to the Ci asterisk in descending order. By following the above steps, a best cloud meeting all the criteria will be selected. In ThinkAir, method level offloading is adopted. Basically, methods are migrated from the smartphone to the ThinkAir server. Thus, processes at mobile side are reduced. At the server side, to handle computation offloading, smartphone virtualization is done. The smartphone acts like a thin client displaying the received results and saving the battery in process. Through task distribution support over virtual machine images, scalability and elasticity is obtained on the server side in ThinkAir. Reduction in execution time and energy consumption of application is attained through parallel processing in ThinkAir. Adaptive code offloading. To react to the continuous changes in the variables and foster an interference model based on the comparison of multiple dependent variables, a system based on fuzzy logic is adopted. A fuzzy logic system consists of fuzzifier, reasoning engine, rules, and defuzzifier. Fuzzifier is used to transform inputs to fuzzy set input. Rules are created based on basic fuzzy operations targeting the variables to control. Reasoning engine is used to make inference based on set of rules. Defuzzifier is used to map fuzzy outputs to normal outputs. In this method, each input parameters like mobile or cloud are considered as input sets and then transformed to respective fuzzy sets. To identify the input set, a linguistic value is created and then translated into possible finite number of input sets. A membership function is associated with fs whose values are extracted from input and arranged in intervals. As in, fuzzy logic system infers a decision based on degree of truth to a specific criteria. By this method of inference of fuzzy logic system, it can be used to quantify how the execution of components can be segregated between local and remote processing. The center of mass formula is applied to compute grade of truth to the decision. While it always not be efficient to do offloading on a cloud as it consumes more battery to upload a task on a cloud due to network issues. To ensure that a user selects best cloud and minimum battery is consumed in the process, MAUI profiler is being used. MAUI profiles the code contained in the functions that are used by the applications and other components known as MAUI profiler. It profiles the corresponding data requirements of the functions. Along with that, the profiler checks the network connections and feeds this information to the solver to determine where to perform the tasks either locally or on remote location. That is, either to process the data on the mobile device or to offload it on the remote location, that is on the server. Then the proxy serializes function calls so that they can run at appropriate locations. MAUI architecture is as shown in the figure. At the mobile side, we have client proxy, profiler, and a solver. At the server side, we have a server proxy, profiler, a solver, and a MAUI controller. The advantages of MAUI is that it is lightweight and can be easily handled by a developer, and it remains seamless to the user. This is done by using a developer tag a function as remotable. This ensures that the functions which access local peripherals cannot run remotely. The solver in the MAUI decides whether to upload the tasks or not. The second advantage of MAUI is that it adapts to the varying environment. The solver, depending upon the factors like network connectivity, battery, etc., decides whether to offload the tasks or not. If the conditions are not in the favor, then the solver tries to do a trade-off between battery, speed, and cost. One of the cloud offloading techniques is CM Cloud. So let's see CM Cloud architecture. CM Cloud architecture consists of master server and compute server. The master server consists of three main components, that is profiling DB, performance estimator, targets and target selector. Profiling DB contains the profile execution information of all offload enabled mobile applications on the reference model server. Performance estimator predicts the application performance on a current candidate target server by analyzing the profile information on the reference model server and differences in server specification and utilizations between the reference model server and the candidate target server. And the target selector finds the most cost-effective target server. The compute server consists of three components: manager, performance monitor, and immigrator. Manager communicates with the server and other components. It also does the jobs by replying to the request made to it. Performance monitor oversees quality of service criteria of the tasks given to the server. It ensures that quality of server is being maintained for the given task. If not, then the immigrator is being used. If the quality of service for a task fails for a given server, the task is being migrated to other server. First, when the offloading request is being made, the performance estimator collects the estimated performance from every server. Based on this information, target selector finds out the most suitable server which has the adequate resources for processing the offloaded data. Using a random server will not fetch the desired result of optimum utilization of the resources. Hence, target selector is being used. Its job is to find a server whose resources are just adequate to satisfy the needs of the offloaded data without compensating on the result. If the resources required for the computation of the offloaded data are more than the available resources in the server, then new server is added. The advantages of CM Cloud are as follows. The cost is cut down by offloading as many applications on the server as possible. 84% improvement in the data center throughput is obtained. 83% reduction in number of service failures in comparison with static light load scheme while improving the throughput by 31%. As battery of mobile devices is retained by offloading computation-intensive tasks on the cloud, it is necessary that energy is saved while computing these tasks on the cloud. This technique, that is GEM Cloud technique, saves energy while computing a task on the cloud. It does so by using scattered mobile devices to process tasks in parallel and uses server-client protocol. The flowchart of server-client protocol is as shown in the diagram. It consists of client, server, and database. Client, it checks device status. If device is ready, it connects to the server. Otherwise, it won't connect to the server. Server receives client information and pass it to the database for updating it. Server then checks if client needs an update. If it doesn't need update, it distributes the tasks based on the client info. If it needs update, then it sends update to the client. The server-client protocol divides the user input tasks on the client to be processed. If the size of the computation task is small, then the server will reduce the load on each client, thus decreasing the turnaround time for the tasks. हे कोण चालू करणार ब्रो? ठीक आहे थांब. To implement optimization techniques, two things need to be considered. First, changes must be made in application software architecture and complex operating system. It is necessary to make correct calculations of response time and offloaded energy. These two factors are greatly dependent on the wireless network quality and wireless interface in use, which varies a lot. Like whether to go for 3G or 4G, as 3G consumes less power but has slower data rates as compared to 4G. And 4G, on the other hand, has higher data rates but consumes more power. The trade-off between them varies across the location. Hence, middleware use is becoming popular. The advantages of having a middleware in cloud computing is there is no need to change the architecture or OS of the devices. Second, it provides flexibility and standardization. A middleware that can be used in mobile to cloud computing is Aura middleware. It provides energy efficiency and performance robustness. It does so by utilizing various resources like type and status of available wireless networks, the capabilities of cloud servers, and the application, communication, or computation intensiveness. It analyzes data for the network type, app type, cloud capabilities, and network conditions by using an unsupervised Q-learning machine learning technique to select an optimal cloud and network type and time to offload. It is proved that there has been 30% improvement in battery life and 25% better response time as compared to the state-of-art fuzzy logic based offloading approach. Scheduling techniques. Processing of resource-rich applications using offloading methods can improvise the battery usage of the devices and increase its efficiency. But to ensure that the latency is also minimized while processing a task, scheduling is important. As a good scheduling algorithm will direct a task to a server and process it within its delay time frame. Hence, scheduling techniques play an important role in cloud computing, mainly when the data traffic rate is high. These techniques process the data sequentially considering different factors and thus minimizing the load on cloud. The first scheduling algorithm is IGA-FCM, which stands for Immunity Genetic Algorithm Fuzzy Clustering Method. This algorithm is an extension of FCM. This algorithm consists of three parts, that is resource clustering, resource scheduling, and source matching. In resource clustering, basically to reduce the screening data volume, large number of resources are decomposed. In resource scheduling, by using algorithm of fast searching, the top end results are selected. In score matching, based on the demand and resources performance, the best candidate from the queue is selected by the dispatcher and returned to the user. This algorithm has a good convergence required for reclustering of resources as compared to the FCM algorithm. It happens to be best than the FCM algorithm because genetic algorithm finds the approximate center for a global search instead of finding the local optimal solutions. As compared to the traditional mean-mean algorithm, the proposed algorithm increases the efficiency in the scheduling process as it improves the demand hit factor. The customer satisfaction measurement is more in the proposed algorithm as compared to the mean-mean algorithm. The advantages of the proposed algorithm are: first, it customizes the rating mechanism. Second, reduces the scale of resource scheduling and real-time screening of candidate results. Third, capability to monitor dynamic resources. Other way to improve the capabilities of mobile devices to handle traffic done by mobile service provider can be improved by integrating the cloud radio access network with the mobile edge cloud computing technology, but a lot of power is consumed and profits obtained are less. In order to solve this problem, a joint scheduling of network resources in radio access network and computation resources in mobile edge cloud computing is done. This object is obtained by implementing the extended version of Lippanova technique and by formulating resource scheduling issue as a stochastic problem. As in real world, the job request won't be of fixed length and finish within the stipulated time frame as assumed by the traditional technique. Hence, an extended version of the technique is implemented and a new algorithm called varied length is proposed. For job request varying in length, this algorithm makes online decisions in consecutive time. The advantages of this algorithm are it maintains low congestion, strong system stability, gives 1 by V diminishing gap. Important feature of cloud computing are virtual machines, which are built as per the client request. Jobs are processed and executed randomly in virtual machine. The downside of it is that the tasks which have long runtime end up using the virtual machines for the longer time. And in turn, the small tasks have to wait for a long time. The solution for this problem will be if the current tasks have more millions instructions per second as compared to the virtual machines millions of instructions per second, then a new virtual machine is created on the same physical machine. Security techniques. Along with different techniques to offload the data to ensure minimum latency and battery, the other factor that needs to be considered is security of offloaded data. To prevent unauthorized access to offloaded data, different techniques can be implemented. If these techniques are collaborated with offloading methods, then a reliable and secure cloud communication can be obtained. First, I'm going to talk about non-biometric security techniques, that is multi-token authorization. In multi-token authorization, tokens are being generated for single access to resources. Here, two tokens are being generated. Identity management system generates a token and sends it to the user and cloud. At the same time, cloud too generates one token and sends it to the user. The token sent by the identity management system and the token sent by the cloud to the user are stored in the cloud database. When the user wants to access data from the cloud, it sends both the tokens. The cloud then will compare the tokens with its database. If it is a match, then the user is granted access to the data. If not, it is not granted access. The advantages of this technique are that it provides access only to the authenticated users. And on the downside, this technique is susceptible to brute force attack. Second is the cloud database can be hacked and the tokens can be obtained. Biometric authentication techniques are very common in today's era. These techniques can be used to provide secure and reliable communication in mobile to cloud offloading. Here, fingerprint image is captured by the mobile phone camera used as a biometric sensor. The captured image is stored in cloud database. Whenever the user wants to access or offload data, it must go through validation process. It is done by scanning the fingerprint of the user. If the user's fingerprint matches with the fingerprint in the database, access is provided. Otherwise, not. Second type of biometric authentication will be where the biometric authentication is being secured by passing an ID number to a given fingerprint. Sometimes users want to extract a data on a cloud from web server. An ID number is provided by the authentication server to obtain a fingerprint template from the database and is compared with the input fingerprint within the stored one. Using fingerprint identification and secure data transmission by doing mixed encryption increases the efficiency of cloud storage authentication. The downside of biometric authentication, that is fingerprint scanning, is that fingerprints of the users can be easily obtained. In this method of authentication, the system takes two inputs, an image of an ear and retina of the user. These images are stored in database and processed for easier access. Two algorithms are used for processing. First is image level fusion. This algorithm integrates different information into a new image for processing of a task. Second algorithm is multi-level fusion. This algorithm does classification of image. The upside of this method is that dual protection to offloaded data, as two inputs are being taken from the user. The downside of this technique is that key generation algorithm is hard to implement for generation of crypto keys. And as there are two inputs taken from the user, the database of the cloud increases, thus increasing the cost. To improve the key generation process in traditional biometric algorithm, a new distance-based key generation algorithm is proposed. In traditional biometric algorithm, a key is generated by extracting minute points from the image. In the proposed algorithm, centroid C for the given fingerprint image is identified. By using the algorithm, a key is being generated. It simplifies the process of generating the crypto keys as compared to the traditional algorithms. It can be concluded that mobile to cloud offloading has a great scope in increasing battery life of mobile devices by offloading the tasks on the third-party server, that is cloud. These servers not only consume less power but also process the tasks in less time. This is possible because the servers have abundant resources to process the tasks. Along with that, the advantages of offloading are lower bandwidth requirements, data charges, and usage. But there are few limitations to this technique. First, the three factors that act as a barrier to adoption of mobile to cloud computing are privacy, security, and trust. Second, environmental uncertainty. Due to changes in environment, the resources won't be easy to access. Third, adoption of this technique in day-to-day life by people. Hence, techniques that not only provide reliable communication and minimize the battery requirements of the phone, but also that ensures the user that uploaded data is in safe hand by using high-end encryption algorithms and which are easy to adopt by common people should be researched. Thank you for your time.